morning and welcome to my first ever YouTube channel. My name is Joanna Sheen Raimonde Labad-Labad, and once again, good morning. Especially to our dedicated, active, and talented instructor, Mr. Ryan Labrador. Sir, good morning. And for today's video, I'm going to discuss the three mathematicians I've chosen to present their lives and contributions in the field of mathematics. But before I start my discussion, let's first discuss what mathematics really is, what its purpose in everyday life, and its contribution in the world. So, mathematics is the science that deals with the logic of shape, quantity, and arrangement. Math is all around us. In everything we do, it is the building block for everything in our daily lives, including mobile devices, architecture, art, money, engineering, and even sports. Mathematics is everywhere. They always exist, and we can't avoid them. We can't avoid math. Whether we like it or not, we must like it. So let's proceed to our famous mathematicians in the world who spend their time, efforts just to provide a great contribution in the name of mathematics. So let's proceed to our topic, which is the mathematics in the modern world. So these are the three mathematicians. We have Andrew Wiles, David Hilbert, and Henry Briggs. So the first mathematician is Andrew Wiles. So Andrew Wiles is an illustrator, English mathematician, and currently a research professor at the University of Oxford. He is known to his contribution to a number of theory. Similar to other mathematicians, he had made great development in the theory. Moreover, his popularity is linked to providing the Fermat's last theorem. He is awarded the 2016 Abel Prize for the distinguished work. Let's proceed to his biography. Andrew Wiles, or Andrew John Wiles, was born on April 11, 1953 in Cambridge, England. His father is Maurice Frank Wiles, was a chaplain at Ridley Hall, Cambridge. Wiles received his education from the Lay School and King's College School, Cambridge. He claims that when he was 10, he came across Fermat's last theorem on his way back home. He understood the theorem at such young age but found it highly fascinating. That no one has proven it yet. Hence, he decided to be the first one to do it. In 1970s, he collaborated with John Coates to explore the arithmetic of elliptic curves. Another colleague that he worked with was Barry Mazur on the idea of Iwasawa theory. In 1986, successive attempts were made to prove the Fermat's last theorem by mathematicians like Ken Ribet, Gerhard Frey, and Jean Perry Sire. Here are his contributions in the field of mathematics. So he has devoted all his energy and time at solving the problem at the expense of his other research work. Wiles dedicated 6 years of his life in that attempt and was secretive of his work. He covered up his tracks by releasing prior researches in fragments and confided exclusively in his wife about his progress. He finally went on record about the proof at a conference in Cambridge in June in June of 1993, Wiles' colleagues commented that he didn't even hint about providing the Fermat's last theorem and just announced that as an afterthought at the end of his lecture. Wiles spent another year trying to upward a solution to a problem. His former student, Richard Taylor, lent a helping hand and they finally circumvented the problem. With this new development, Andrew Wiles finally proved the theorem, the Fermat's last theorem. So let's move on to our next mathematician, which is David Hilbert. So David Hilbert's biography David Hilbert was a great leader and spokesperson for the discipline of mathematics in early 20th century. But he was an extremely important and respected mathematician in his own right. Like so many great mathematicians before him, Hilbert was another product of the University of Göttingen at that time, the mathematical center of the world, and he spent most of his working life there. His favorite years, though, were spent at the University of Königsberg, where he developed an intense and fruitful scientific exchange with fellow mathematicians like Hermann Minkowski and Adolf Horwitz. So let's proceed to his contributions in the field of mathematics. So, a German mathematician, David Hilbert, 1862 to 1943, contributed a great deal to mathematical logic, as well as mathematics in general. So in 1890 his proof of the theorem of the invariance replaced earlier work on the subject and paved the way for modern algebraic geometry. By 1897, his algebraic number theory led to many developments in that field. So his contributions also include discoveries in number of theory, mathematical logic, differential equations, multivariable calculus, Euclidean geometry, and even mathematical or theoretical physics. Hilbert is most well known for presenting Hilbert's problem, which originally were a set of 23 unsolved mathematical problems that he hoped would eventually lead to many more disciplines with the field of mathematical. Additional to his contribution, in his book, The Foundation of Geometry, Hilbert described a set of axioms that removed the flaws of Euclidean geometry. These axioms unify plane geometry with the solid geometry of Euclidean into a single system. Hilbert is considered to be one of the most influential mathematicians in the field of geometry. Hilbert's 23 problems are the most influential list of open problems of all time. Hilbert's problem lead to development of the formalist school of mathematics. Hilbert started a research program that came to be called Hilbert's Program, in which he aimed to formulate math on a solid logical foundation. Hilbert believed this would be possible by showing that all of math follows a finite system of axioms which could be proved. So this came to be called formalism. Hilbert proved the finite basis theorem for multiple variables. So Paul Gordon had been able to prove the theorem earlier, but only for two variables. Hilbert approached the problem in a different way. advancing algebraic number theory. So, here are Hilbert's 23 mathematical problems, opening address. So, we have here problem 1, Cantor's problem of the cardinal number of continuum. Number 2, problem 2 is the compatibility of the arithmetic axioms. Problem 3 is the equality of two volumes of two tetrahedra of equal bases and equal altitudes. Problem 4, problem of the straight line as the shortest distance between 2 points. Problem 5, Lie's concept of a continuous group of transformations without the assumption of the functions defining the group. Problem 6, mathematical treatment of the axioms of physics. Problem 7, irrationality and transcendence of certain numbers. Problem 8, problem with the distance distribution of prime numbers. Problem 9, proof of the most general law of reciprocity in any number field. Problem 10, determination of the solvability of a Diophantine equation. Problem 11, quadratic forms with any algebraic numerical coefficients. Problem 12, extension of Kroneker's theorem on abelian fields. Problem 13, impossibility of the solution of the general equation of the 17th degree. Problem 14, proof of the finiteness of certain complete system of functions. Problem 15, rigorous foundation of Schubert's calculus. Problem 16, problem of the typology of algebraic curves and surfaces. Problem 17, expression of definite forms by squares. Problem 18, building space from congruent polyhedra. Problem 19 are the solutions of regular problems in the calculus of variations, always necessarily analytic. Problem 20, the general problem of boundary curves. Problem 21, proofs of existence of linear differential equations having a prescribed monodromic group. Problem 22, uniformization of analytic relations by means of automorphic functions. Problem 23, the last problem, further development of the methods of the calculus of variations. So, David Hilbert was an extraordinary mathematician, for he contributed most of his time in the field of mathematics. So let's proceed to our last but definitely not the least mathematician, which is Henry Briggs. So Henry Briggs' biography. Henry Briggs, February 1561 to 9 January 1630, was an English mathematician notable for engaging the original logarithms invented by John Napier into common base 10 logarithms, which are sometimes known as Briggsian logarithms, in his honor. Briggs was a committed Puritan and uninfluential professor in this time. So, his personal life, he was born at Warley Wood near Halifax in Yorkshire, England. After studying Latin and Greek at a local grammar school, he entered St. John's College, Cambridge in 1577 and graduated in 1581. In 1588, he was elected a fellow of St. John's. In 1592, he was made reader of the physical lecture founded by Thomas Lenacre. He would also read some of the mathematical lectures as well. So in 1596, he became first professor of geometry in the recently founded Gresham College, London, where he taught geometry, astronomy, and navigation. He would lecture there for nearly 23 years and would make Gresham College a center of English mathematics, for which he would notably support the new ideas of Johannes Kepler. He was a friend of Christopher Hayden, the writer on astrology. Through Briggs himself rejected astrology for religious reasons. So let's proceed to his contribution. In 1616, Briggs visited Napier at Edinburgh in order to discuss the suggested change to Napier's logarithms. The following year, he again visited for a similar purpose. During this conference, the alteration purpose proposed by Briggs was agreed upon. On his return from his second visit to Edinburgh in 1617, he published the first Chiliad of his logarithms. In 1619, he was appointed civilian professor of geometry at Oxford and resigned his professorship of Gresham College in July 1620. Soon after his settlement at Oxford, he was incorporated Master of Arts. In 1622, he published a small tract on the Northwest Passage to the South Seas through the continent of Virginia and Hudson Bay. The tract is notorious today as the origin of the cartographic myth of California as an island. In it, Briggs started he had seen a map that had been brought from Holland that showed California Island. Briggs' tract was republished 3 years later, or in 1625, in Forbes' His Pilgrims, Vol. 3, page 848. So, in 1624, his Arithmetica Logarithmica, in folio, a work containing the logarithms of 30,000 natural numbers to 14 decimal places. 1 to 20,000 and 9 to 90,000, 1 to 100,000. This table was later extended by Adrian Bloch, but to 10 places, and by Alexander John Thompson to 20 places in 1952. Briggs was one of the first to use finite difference method to compute tables of functions. He also completed a table of logarithmic sines and tangents for the 100th part of every degree to 14 decimal places, with a table of natural sines to 15 places and the tangents and seconds for the same to 10 places, all of which were printed at Goda in 1631 and published in 1633 under the title of Trigonometria Britannica. So this work was probably a successor to his 1617 logarithm Chilias, or Logarithmorum Chilias Prima, the first 1,000 logarithms, which gave a brief account of logarithms, and a long table of the first 100 integers calculated to the 14th decimal place. So, let's proceed. Briggs discovered in a somewhat concealed form and without proof the binomial theorem. English translations of this Trigonometria Britannica are available on the web. You can also search them. Briggs discovered in a somewhat concealed form and without proof the binomial theorem. English translations of his Trigonometria Britannica are available on the web. You can also search this one. So Briggs was buried in the chapel of Merton College, Oxford. Dr. Smith, in his Lives of Gresham Professor, characterized him as a man of great probity, a consumer of riches, and contented with his own station, preferring a studious retirement to all the splendid circumstances of life. So those are the three famous and extraordinary mathematicians who still exist in our modern world, who spend their time, effort, and knowledge just to provide the best and great solution in the field of mathematics. Once again, my name is Juan Shin Ramon de Labad. Thanks for watching this video. I hope that you learned something today. Keep safe and stay at home. Bye!